Welcome again to Formula 1 Maths. This is the follow-up video I promised to do for 5.1 of the A-Level Applied Maths course, Year 2. You remember that we solved these two questions here using resolution of forces. And I promised to solve them again using triangle of forces. So for those of you who are viewing this now and they have not viewed the one on resolution of forces, you might not know what I'm talking about. So it would be a good idea if you go and view the one on resolution of forces. So you recall that when we're solving this question, which is asking you to find the magnitude and direction of the resultant force. For A, we got a magnitude of 21.7 newtons. In the direction, we got as 72 degrees above the direction of the vector I. For B, we got a magnitude of 18.1 newtons, and the direction was 8.6 degrees below the direction of the vector I. We should get the same answers using triangle of forces. So let's go and see how it's done. For the first one, A, we begin by drawing the triangle of forces. You do this by simply adding the two vectors. You add the tail of one vector to the head of the other, and then you get your resultant vector. It does not matter which one you start with. I'm going to start with the 15 Newton force, putting my coordinate axis like that to give me a sense of where the angles will be. So I'm going to add the 20 Newton force, again my coordinate axis, and now I can draw in my resultant vector, which will be that. The next thing we do is put in the necessary angles that will help us to do the calculation. So the first angle I put in is 30 degrees. How did I get 30 degrees? So looking at this 20 Newton force, if I draw a line here, that will be the x-axis. This here is 90 degrees, so it means that this angle is 30. That's how I got 30 here. Then this angle here is 45. So there are many ways we can prove that that angle is 45. The first one is drawing a horizontal line like that. This makes this angle 90. If that's 90, if this is 90, and this is 45, then obviously this is 45. 45. We could have also drawn a line here, and because this one here and this are parallel, this angle here is 45 because this and that are alternate angles. We can conclude that this is 45. So that's why this is 45. Now that we have established that, we can go and use Cosine Rule to find the magnitude of R. The magnitude squared is equal to 15 squared plus 20 squared minus 2 times 15 times 20 cos 75, which is the angle here. 45 plus 30 is 75. So evaluate that, and you're going to get 21.7 newtons, as we got before. For the angle, we need to calculate this angle here so that we can conclude that it's an angle above the x-axis, which is that direction. So this is the I component of the vector. So how do you do that? We can do find theta by first of all calculating this angle here. This angle. Here. So we can do that by using sine rule. So sine alpha over 20 must be equal to sine 75 over the R value that we got. Then we go to evaluate that, and we get this, and then we're going to get 63. So this is 63. And as you can see, this is a straight line. And because this is 45, this is also 45. So if you add this and that together and take it out from 180, we get our value for theta. So 180 minus 63 minus 45 equals 72. And that's exactly the angle we got. And we go and formally state our direction as 72 above the direction of the vector I. Next question. Again, let's draw our triangular forces. I'm starting with the 10 Newton force. Then I'll add my 12 Newton force. That gives me this one as my resultant force. Let's put in the angles. This is 30, which is quite obvious. So that's 30. We don't need any explanation for that. That's 30. That's 40 because this is 40. This is 40. Now, we need to find this angle here so that we can use cosine rule again. As you can see, this angle here is 60. Because if I extend this down, I get 90 degrees here. If that's 90, and this is 30, then that is 60. And that is 50, because this here is 90 degrees. So if that's 40, then that must be 50. So I get a total angle of 110. Then I'm going to use my cosine rule. That will be 10 squared plus 12 squared minus 2 times 10 times 12 equals 110. Evaluate that. You get 18.1 newtons, as we had before when we were using resolution of forces. So let's go and find the angle. For the angle, we need to find this angle theta here. So we need to find the whole of this angle here. We're going to use sine rule to do that. So sine alpha over 12, sine alpha over 12 is equal to sine 110 over 18.1, which is R. Do your rearrangement, evaluate, you get and you get 38.5. To get this angle theta, we need to take away 30 from alpha. So theta is equal to 38 minus 30, and that's 8.5, exactly what we got before. And we formally state it as 8.5 degrees below the direction of the I vector. As you can see, the direction of the I vector is here. And that's it for the triangular forces. So you can see that sometimes the triangular forces is easier to use than the resolution forces. But it's up to you to use any method if the question does not state to use one particular method. Okay, thank you for watching, and I'll see you in the next video.